Hello everyone, this is Shivam Mehta, a second semester student pursuing a master's in construction engineering management at CEPT University. We have studio-based learning for our Studio 2, construction project execution, monitoring and control. We have chosen an institutional project for this semester. We'll go through introduction. As mentioned, we have considered institutional project for our studio. The package includes the construction of academic blocks. The location of the project is Sanand, Ahmedabad, Gujarat. The date of commencement is 26th of April 2022. Type of project, institutional project. Scope of work, core and shell work with 2 basement and G+11. Type of contract, item rate per square feet. Cost of project is 114 CR. The key stakeholders are architects, structural consultant, cost consultant, PT consultant, contractor, and quality consultant. Total number of blocks are 2. Total area is of 10,400 meter square. Several site office premises are there. Labor colony for 450 workers and completion time is 20 months. We'll go through LRC, Linear Responsibility Chart. LRC is a tool that defines each stakeholder's responsibilities in accomplishing a job. So these are the legends for the chart, and these are the stakeholders like client, cost consultant, design consultant, structural consultant, PT consultant, contractor, and quality consultant. So totally 29 activities were identified, in which few are shown here, and I'll explain you one of these, like preparation of inspection and test plan, in which the primary responsibility is of quality engineer from contractor side and joint responsibilities of project manager from contractor side and quality consultant engineer, and it is and must consult by client side of both project in charge as well as site in charge. For plus analysis and delta analysis. The plus analysis, every technical concept is communicated by the proper channel of communication between various stakeholders, and a regular meeting related to quality and ongoing activities with the client is done, and an open table discussion between client, contractor and PMC, during which quality related topics are discussed. And for delta analysis, the project manager is involved in 26 activities directly or indirectly, while the senior engineer is involved in 6. So the senior engineer involvement should be more as compared to project manager to reduce the load, and as well as the involvement of architect should be there while preparation of quality assurance. Now we'll see for planning for concrete. The methodology is followed is concrete quantity, peak requirement of concrete, manpower requirement, post schedule, and cost of concrete. So the scope considered for the concrete planning is entire block A. In block A, for basement 2 and basement 1 roof slab is divided into 5 pours, whereas from first floor roof slab, the 11th floor is divided into 2 pours. At the right, you can see the photo of basement 2 roof slab divided into 5 pours. Now we'll see the productivity and concrete quantity requirement as per pours for basement 2 slab, which has a slab cycle of 45 days and which is divided into 5 pours. For like see for pour 1, the concrete quantity required is 321.04 cubic meter, and the productivity is 1.89 meter cube per man hour. Same is as followed for every pour. And for first floor roof slab, the slab cycle is of 25 days. Now we'll see the manpower requirement. For manpower requirement, the manpower is divided as per pore size. If the pore size is less than 400 meter cube, they will require 16 laborers, and if the pore size is greater than 400 meter cube, the labor requirement is 21. And this below graph shows the concrete requirement since April 23 till November 23. So the maximum peak requirement of concrete is in April 23 with 1222 meter cube of concrete will be required. We'll see the pour schedule for entire block A. In this, pour schedule is prepared on 5th of March 2023, in which, as you can see in the legend, like gray shows on time, red shows delay by 4-5 days, orange shows delay by 2 days, green shows delay by 4 days, and pink shows is ongoing. So for basement 2 roof slab, like for pour 1 and pour 2 were on time, pour 3 and pour 4 were delayed by 4-5 days, and pour 5 was delayed by 2 days, and pour 1 was done before planning day of 4, and pour 2 and pour 3 were ongoing. And now we'll see the cost of concrete for floor wise. So like for basement 2, the total quantity of concrete will be required is 2905.5 meter cube with a unit rate of 6870. The total cost for the only basement 2 roof slab will be 1.99 CR. The total cost of concrete is 19 crores 71 lakhs. So now the concrete inference will be the concrete grade used for PCC and RCC work is M40. Concrete coefficient is considered as 0.3 meter cube by meter square, and the total cost of the concrete in rupees is 19 crores 71 lakhs 78,000 including GST. We'll see inventory management. EOQ, economic ordering quantity. Types of EOQ, simple or classic model, model with price break, EOQ model with shortage, reordering point with probabilistic demand. Now we'll see classic EOQ model for steel. Demand of steel is calculated as 3,214.62 ton for the project. Price of purchase price is 60,000. Ordering cost is 3,298.54 rupees, which includes salaries, external test, weight bridge charges. Ordering cost is considered as 10% of purchase price, in which is 6,000. Assume. Now you can see in the table in which we have considered the as per theory formula of UQ and as per the current site practice. So you can see that the total difference is of 4,86,512. So from the above table, it is considered that EOQ comes out to be 59.45 tons, whereas on site the site ordering quantity is 267.88 tons. If contracting firm changes the ordering quantity from 267.88 tons to 59.45 tons, then they can actually save an around of 4,86,512 rupees annually. And now we'll see price break model, in which the first graph shows that the total cost with purchase price and EOQ variation with purchase price. So the major inference for this both the graph is that price break graph shows that the total cost and the purchase was vary linearly, while in EOQ versus purchase price shows the lower purchase the price, lower the total cost, or the vice versa. We'll go through VSM, value stream mapping. It is a lean tool which is used to maximize the value and minimize the waste in each activities. So the methodology is first define the scope of work and identification of sub-activities, then determination of value added time, non-value added time, changeover time and cycle time, then preparation of current state mapping, then identification of waste and elimination of waste, then using lean tool, and then preparation of future state mapping. The activity observed of foam work of column, number of labors observed were 4, and time of observation was from 9 a.m. to 5:15 p.m. This is a section. This is a 3D view of column, and on the right, this is a picture from the side while doing fixing the foam work. So these are the waste identified in sub activities, in which, like in mobilization of material, the waste were identified as waiting and transportation. So waiting for mobilization of material and transportation, like transportation of foam columns. And in preparation of homework for column 1. The defect was of rework of column like cleaning and all. It was observed. An extra process time like oiling and all. And in this, now we'll see value added and non-value added times of all the activities in which the maximum is 53% non-value adding activities type 1. Type 1 means non-value adding activity but necessary. No, type 2 non-value adding. Type 2 means non-value adding activity but not necessary, which is just 13%. Then value adding time is 34%. Now, after that, applying the lean tools such as 5S, Kaizen, Kanban, Pool Plan, PDCA, and Right to First. As this figure shows the future state mapping of all the activities which we have seen in table in previous slide. So here we have added like 5S and Kanban, Kaizen and all. So this graph shows the current state versus future state. The blue represent the current state, the orange represent the future state. In current state, the total cycle time was 462 minutes, and in future state, after applying the lean tools, we reduce the time to 334 minutes. So as now we'll see the take time for completion of one form work. So current take time was 115 minutes and the future time after applying the lean tool were 84 and the targeted take time or you can say it as calculate take time was 75 minutes per one call. So in friends we see like the current cycle time for the form work for the column is 462 minutes which is reduced by 334. So we can see 28% of reduction in time has been seen by applying the lean tool. By applying the six lean tools, we can reduce the process time as well as non-value added time required for an activity which can lead to 28% of time saving as well as the amount or the cost of the total in the project or an activity. Cost of quality. So cost of quality is defined as methodology that allows an organization to determine the extent to which its resources are used for activity that prevent poor quality work, that appraise the quality service and result in deviation of cost. The cost of quality is divided into two sections: quality management cost and quality deviation cost. Quality deviation cost is divided into two: prevention cost and appraisal cost. Prevention cost is divided in preparation of QAP plan and checklist, which has a cost of 20,000. Establishing of quality control laboratory, which has a cost of 1.82 lakhs. Equipment cost is 4.5 lakhs. Training cost is of 2,000. Internal audit is of 63,000. And appraisal cost is divided into two: calibration of equipment which is done annually which has a cost of 49.2 thousand and staff salaries of 14 lakhs. And now we'll see quality deviation cost is divided into internal failure and external. In internal failures we have found two NCs. One NC is of column with honeycombing and second NC is plastic was found on the surface due to which this honeycombing was seen. And external failure is not yet, it occurs when the site is handed over to the client. So now we'll study the NC1 in detail, in which the NC1 deals with the honeycombing of column TC7. So in this, the maximum cost which was occurred in material which has an 41,000 cost, which is the 90% of the total cost, which is then followed by equipment, which is 2,700, then labor cost with 1,100 and supervision cost of 688 rupees. So the total cost for NC1 was seen like 45,495. Then NC2, where the plastic was found in C24, the maximum cost was in labor was 40%, which has 800, then followed by supervision cost 34% with 688, then material cost, which is 26%, which is of 508 rupees. Now for inference, the proper training should be given in which shuttering should be properly done, no slurry loss should be allowed, use of proper vibration machine should be there, proper supervision is required. Concrete should not be done from height more than 1 to 3 meters, and like training should be given to all like supervisor, casting and shuttering workers. Now we'll see contract administration. We'll study activities of contract administration procedure, and time delay analysis. The activities of contract administration follows of procurement of contract administration, then comparison of GCC's SCC's clause from FEDIC with tender, then risk assessment, clause management, identification of claims, then process of RA bill, time delay analysis, process of extra item, checklist of contract administration. Now we'll see contract administration procedure in which the first appointment of contract management team is done, then contract formulation is done, then preparation of contract management plan is prepared, in which it includes monitoring, reporting, and evaluation, then claim management, risk identification and its analysis, and disputes management. At the last, the contract closeout has been done. Then now we'll see time delay analysis. The time delay analysis deals with the delay which are occurred on site due to which our milestone have been delayed. So basically there are three descriptions in which it concerns rainfall, shortage of steel on site, and change in drawings. So the maximum delay is occurred due to shortage of steel on site, which is of 54%, and when we see in days is 41 days. And the milestones which are affected are raft foundation, second basement roof slab of pour 5 work has affected, and of pour 2 for ground floor roof slab, which is followed by rainfall is 31%, with number of days is 23, where the milestone affected is excavation work and raft foundation. Then after that, which is followed by change in drawing, which is 15%, which has a delay of 11 days. And the major changes affect milestone is basement 1 of pour 5. The total delay is of 75 days. So, these are the key learnings for each topic which has been shown in portfolio. Thank you.